Hello. You should have your Unit 10 Day 1 notes out. We're going to be talking about radicals. We've already kind of done some stuff with it throughout the semester, last semester, but we're going to do more with it this unit, so it'll be really important that you know how to deal with radicals. First thing is, what makes a number a perfect square? A perfect square is when you square root the number, square root the number, and you get a whole number. You don't get a decimal or anything. Get a whole number. So examples of perfect squares are like 4 or 9, 16, because square root of 16 is 4, square root of 9 is 3, square root of 4 is 2. Other perfect squares to be familiar with are 25, 36, 49, 64, 81, 100, etc. All right, so perfect squares are going to be something that you'll run into from time to time. Radical rules. No perfect squares can be left under the radical. No negatives can be allowed under the radical. And no radicals in the denominator. All right, so we're going to be dealing with problems that have one of each of those and how we fix those. So examples. These are just simplifying radicals. We did this last semester. Remember, we did little factor trees. You want to break it down to prime numbers. So like 25 times 3 is 75. 25 breaks down to 5 times 5. Remember, you circle the pairs. For each pair, you write the number down once. Any leftovers stay under the radical. So pairs go outside, leftovers stay under, and that would be 5 root 3. Square root of 90 is 9 times 10. 9 you could do 3 times 3, 10 you can do 2 times 5. So you have a pair of 3's, you write that number down once, and then the leftovers, the 2 and the 5, stay under. So you end up with 3 root 10 for your answer. Square root of 27, you do 9 times 3, break down the 9 to 3 times 3. You have a pair of 3's that goes on the outside, and the leftover 3 stays under. Now, if something like 405, if you don't know what multiplies by 405, use your calculator. Divide by 2, divide by 3. If it ends in a 5 or a 0, it's probably divisible by 5 or 10. Since this ends in a 5, I know for sure 5 goes into it, and it ends up being 81. 81 breaks down to 9 times 9. Now, you could break down the 9's further, but since I have a pair, I'm just going to circle it. Anytime you run into a pair, even if it's not prime, stop right there and circle it. It'll save you a little time. We have a pair of 9's, and then the leftover 5. All right, even if you broke the 9's down, you'd still end up with 9 root 5. All right, so that's kind of simplifying radicals. Let's go down to multiplying radicals. Innies and outies. When multiplying radicals, you can multiply what is inside the radical by what is inside the radical, and what is outside the radical by what is outside the radical. Innies and outies don't mix. Be sure to simplify. All right, so let me show you what I mean by this. So in these problems, the 2 and the 3 are considered outies because they're outside the radicals. The 5 and the 6 are considered innies. They're inside the radical. You cannot multiply an outie with an innie, so you couldn't multiply like 2 and 6. Multiply the outside numbers together. 2 times 3 is 6. Multiply the inside numbers, 5 and 6, together. Now, if you can break that down and simplify it any further, like if there's any pairs, make sure you do so. 30, we can't really break that down any further, so it's 6 root 30 would be our answer. All right, same idea with number 8. 4 and 5 are outside, they get multiplied. The numbers underneath, 6 and 2, those get multiplied. Now 12 breaks down to 4 times 3. 4 breaks down to 2 times 2. So we have a pair of 2's that is going to join the 20 out in front, and then the leftover stays under. So you end up with 40 root 3 for your answer. Over here, we have, technically this is like a 1 root 3, so you're multiplying 11 times 1, and then root 3 times root 3 is square root of 9. Square root of 9 is 3. All right, square root of 9 is just plain old 3, not root 3. And then you multiply those together, you get 33 for your answer. For this guy, you do 5 times 3, you get 15. 6 times 12, you're going to get 72. And then you just break it down. 36 times 2, 36 breaks down to 6 times 6. So notice we have a pair of 6's. I'm just going to stop there. The 6's are going to join the 15 out in front, and the 2's underneath. You multiply it together, you get 90 root 2. And that would be your answer for that one. All right, so that's multiplying. This is adding radicals right here. When adding or subtracting radicals, you need to have like radicals. So like you can only add a root 2 with a root 2, or you can only add a root 3 with a root 3. Then you can simply add or subtract the coefficients. So something like this, 3x plus 5x plus 2y plus 4y. You can only combine like terms. You can only combine the x's together. 3x and 5x is 8x, and you can combine the y's together. Smiley faces and frowny faces. You can combine the smileys. You got 8 smileys, and then you've got 6 frownies. All right, same with radicals. You can only combine root 2's with root 2's, and when you do, you add the coefficients. 3 plus 5 is 8 root 2. Hopefully that makes sense. You've got 3 root 2's plus 5 more root 2's makes a total of 8 root 2's. And then you've got the root 7's. 2 root 7 plus 4 more makes 6 root 7's. Notice the radical underneath doesn't change. So when you do something like number 13, it looks like nothing can combine because none of them have the same number under the radical. However, what you can do is you can simplify a little bit. So 75 breaks down to 25 times 3. 25 breaks down to 5 times 5. So you have 5 root 3. The 27 breaks down to 9 times 3, or 3 times 3 for the 9. So you got a pair of 3's and a leftover 3. Notice there's a minus there. And then we still have 5 root 3 at the beginning. These all have root 3's, so that means they all can be combined. You just combine the coefficients. 5 and 5 is 10. 10 minus 3 is 7. So it would be 7 root 3. Number 14, same idea. You can simplify these a little bit. Let's see, the 8 breaks down to 2 times 2 times 2. So the 2 is going to join the 4 out front. 4 times 2 is 8, and we still have the leftover 2. 50 can break down to 25 times 2, or 5 times 5. So we've got a pair of 5's and a leftover 2. 5 is going to join the 3 out in front. 5 times 3 is 15. Notice there's a minus. And then the leftover 2 stays under. And then the 12 breaks down to 3 times 4, 4 breaks down to 2 times 2. So the 2 is going to join the 7 out in front, 2 times 7 is 14, and then we still have the leftover 3. Now only 2 of these can be combined, the ones that have the root 2's. 8 root 2 minus 15 root 2, you just do 8 minus 15, that's negative 7 root 2, and then we still have plus 14 root 3. All right, so that's adding and subtracting. You probably saw that a little bit last year in algebra at the end of the school year. Rationalize the denominator is something that we're going to be doing a lot of when we get into special right triangles this week. Since radicals cannot be left in the denominator, we have to rationalize the denominator. To do so, we multiply the top and bottom by the simplified radical that is in the denominator. This will turn the denominator into a rational number. So here's what's happening. You're going to be multiplying by whatever radical is in the bottom. So if you have a root 5 in the bottom, you're going to multiply the top and bottom by root 5. And the reason why is because root 5 times root 5 is the square root of 25, which is 5. It'll always turn into a nice number, no radical. Like if you have something like square root of 10 times square root of 10, well that's the square root of 100, which is 10. Any radical times itself will be that number under the radical. Square root of 2 times square root of 2 will be 2. Square root of 1,000 times square root of 1,000 will equal 1,000. So like number 16, if we want to multiply by the radical that's in the denominator, you do root 6 times root 6, which is square root of 36. Well, square root of 36 is 6. And then 1 times root 6 is just root 6. If you want to put the 1 there, you can, but it's not necessary. Now, you cannot cross off those 6's because 1 is under a radical and 1 is not. You can only reduce or cancel if they are both under a radical or both not under a radical. Since 1 is under and 1 is not, you can't reduce any further. Number 17, we want to get rid of the root 2, so we multiply the top and bottom by root 2. On the bottom, square root of 2 times square root of 2 is 2. And then on the top, remember, you cannot combine one that's under a radical and one that isn't under a radical. So technically that's 1 root 2. You can multiply the 6 and the 1, giving you 6, and then you still have root 2. Now, you cannot do anything with the 2's, but you can reduce the 6 on the top with the 2 on the bottom. 6 divided by 2 is 3, and then there's still a root 2 there. 18, same idea. You can multiply the top and bottom by root 3. On the bottom, root 3 times root 3 is 3. On the top, you cannot multiply the 3's to make 9. Technically, that's a 1 root 3, so you end up with 3 root 3. Now, the 3 on the top and the 3 on the bottom, those can reduce. 3 over 3 is 1 root 3. The 1 is optional, but that's going to be your answer. 19, you want to get rid of the root 3. No, don't need to worry about the 2. And so you multiply top and bottom by root 3. On the bottom, root 3 times root 3 is 3. You still have the 2. And then on the top, you have 7 root 3. On the bottom, you have 6, because 2 times 3 is 6. Oops, I made a mistake there. So You have 7 root 3 on top and 6 on the bottom. If you could reduce 7 over 6, you would, but you can't. You cannot do anything with the 3 and the 6 because one's under a radical and one is not. For number 20, you can multiply the top and bottom by root 2. You have 10 root 2 on top. Remember, you cannot multiply those because one's under a radical and one's not. On the bottom, root 2 times root 2 is 2, and you still have a 3. Now, 3 times 2 is 6. And then if you notice, 10 over 6 can be reduced. Just divide them both by 2, and you'll end up with 5 root 2 over 3. 12 or 21, you could simplify the square root of 12 first because there is a perfect square that goes into that. Technically, square root of 12 is 2 root 3. And then you could just multiply the top and bottom by root 3. If you don't want to do that and you'd rather just multiply the top and bottom by root 12, you could. It just makes it a little bit longer. On the top, you'll have 8 root 3. On the bottom, root 3 times root 3 is 3. 2 is still there. So you have 6 on the bottom and 8 root 3 on top. Now you can reduce the 8 over 6. You can divide them both by 2. You get 4/3, and then there's still the root 3 there. For 22, you'll notice that there's a big old square root. If you want to you can always split it up into 2 smaller square roots. So if you have one big one, you can make it 2 little guys. Square root of 9 is 3. Square root of 50, we could break that down a little bit. We have 25 and 2. We could make it 5 root 2. And then after that, then we can multiply the top and bottom by root 2. You get 3 root 2 on top. Root 2 times root 2 is 2, and there's still a 5 there. So on the bottom you end up with 10, and on the top you have 3 root 2. If you could reduce 3 over 10, you would, but we can't really do anything with that. All right, we're going to skip those two. We're going to go to the very last part, solving equations with radicals. Solving equations with or without radicals is done the same. To undo multiplication, we divide both sides by the same number. We do the exact same thing with radicals. So like something like 25, you've done this many times. You divide by 3 to get x by itself, you get 8. If you have x times root 3, to get rid of the root 3, you divide both sides by root 3. And so the root 3's on the left cancel, and on the right you're left with 24 over root 3. And then it's exactly like the problems we just did. You got to rationalize the denominator. You have 24 root 3 on top and 3 on the bottom, and then you can reduce the 24 and the 3 on the bottom. 24 divided by 3 is 8 root 3. So x is going to equal 8 root 3. Something like 28. We have 3x root 2. We want to get rid of everything but the x. So we're going to divide by 3 and root 2. So it looks a little bit weird, but that's what we're going to do. These cancel. We're left with x equals 18 over 3 root 2. Now you could get rid of the radical 2 first, but I'm going to reduce. 18 over 3, that's the same thing as 6 over 1, or just 6, and then the root 2 is still on the bottom. And then you can rationalize the denominator. You end up with 6 root 2 on top, and then root 2 times root 2 is 2. Divide, you'll get 3 root 2 for your answer. All right, 30, same idea. It's x times root 2. So you're going to divide both sides by root 2. These cancel. You're left with root 13 over root 2. You need to rationalize the denominator, so you multiply both sides, both the top and bottom, by root 2. Now these are both under a radical, so you can multiply those. You get 26, and then root 2 times root 2 is 2. Now you could try and break down the square root of 26 to see if there's any perfect squares that we could pull out or any pairs. There isn't any. So you end up with square root of 26 over 2. And that's about all you can do. Can't reduce it because one's under a radical and one isn't. Alright, so that kind of gives you a general idea. We're going to be doing a lot with radicals. What you're going to be doing now is you're going to be working on the Unit 10 homework, and your teacher will tell you all about that. I believe it's numbers 1 to 33 in the Unit 10 packet. Alright, thanks.